Lesson 1.4, working with negative exponents. So we're going to start working with negative exponents, and I'm going to cover it over two different lessons, lesson 1.4 and 1.5. Bear with me, guys, a little bit of tedious writing for this one because we need to find a pattern to associate and to figure out the rule for negative exponents. So we're going to fill in this chart. So if I look at the first column, I have some division here. 2 to the power of 3 divided by 2 to the power of 5. Well, we already know that we can subtract the exponents here using the division rule. A to the m divided by a to the n equals a to the m minus n. But we want to find a pattern for negative exponents. So what we're going to do is rewrite this question using repeated multiplication. So I have 3 2's in the numerator and 5 2's in the denominator. And so what's nice about this is I can go in here and cancel some of the 2's out. So I'll end up getting 1 in the numerator, and I still have 2 2's in the denominator, which I'm going to write as a power, 2 to the power of 2. Let's do it again. So division of 5 divided by 5 to the power of 5. Remember, there's an exponent of 1 here. So if I use the exponent rule, I would get 1 subtract 5, which is 5 to the power of negative 4. And if I use repeated multiplication, I have 1 5 in the numerator, 5 5's in the denominator. And if I simplify this, I'm going to rewrite this as 1 in the numerator and 4 5's in the denominator, which I'm going to write as 1 over 5 to the 4. What happens if I have negative bases? This one's a fun one. So remember, if I have negative bases, so the 4 applies to the negative 3, the 7 applies also to the negative 3, so I can subtract the exponents. 4 subtract 7. And I'm going to write this as negative 3 to the power of negative 3, and I'll leave that like that for now. If we write this in repeated multiplication, I'm going to have 4 negative 3's in the numerator and, oh my gosh, 7 of them in the denominator. So we can see that we don't want to do this every time, but we're going to learn a rule based on this in a minute. 1, 2, 3, 4, 5, 6, 7. Great. So I'm going to cancel out all 4 of those with 4 in the denominator, and I'm going to get 1 over negative 3 4 times. And guys, let's skip this. I can just write that as negative 3 to the power of 4. Okay, one more, and then we'll make a generalization. So I can also do this with a fractional base. My base here is 1/2. So I can use my exponent rule, 1/2 to the power to the exponent of 2 minus 4. That's 1 over 2 to the power of negative 2. So this one might look a little bit weird, but fraction bases are still bases. So what I do is I repeatedly multiply 1/2, 2 times in the numerator, 4 times in the denominator, and I am going to cancel out 2 fractions, and I get 1 over 1/2 times 1/2, which I will write as 1 over 1/2 squared. Okay, let's make some conclusions here. So basically, what I want to do is compare the exponent rule answers with the repeated multiplication answers, because this is math. We didn't change anything, everything still equals everything. We've just changed the form. So 2 to the negative 2 is the same as 1 over 2 to the power of 2. 5 to the exponent negative 4 is 1 over 5 to the exponent positive 4. So we can kind of see that what the negative exponent does is it boots the base from the numerator into the denominator. Oh, I did something wrong here. Oops, this should be a 3. Okay, so I have negative 3 to the exponent negative 3 is 1 over negative 3 to the positive 3. Guys, let's simplify this. We don't want brackets around our exponents. And because this is odd, okay, I know this is going to end up being 1 over negative 3 to the power of 3, but we don't like negatives in the denominator, I mean, so we're going to move it to the numerator. Okay, so this ends up being negative 3 to the power of 3. And finally, 1/2 to the negative 2. As I said, even though it's a fraction, it's still just a base. We treat it like a base, so we're going to leave it like that for now. In our next lesson, we're going to realize that we should actually be simplifying this, and we'll talk about how to do that a bit later. But right now, I want to generalize a bit better with our by using a variable as a base. So if I have x to the exponent 9 and divided by x to the exponent 9, that's x to the exponent negative 4. And we know that what this is going to be is a 1 over 4 x's. So what we can say, which is 1 over x to the positive 4, so x to the negative 4 equals 1 over x to the 4. Okay, there is another way to think of negative exponents, which I'd like us to do. Let's look at the patterns here. Okay, so we're going to do this by evaluating. So 2 to the power of 3 is 8. 2 to the exponent 2 is 4. 2 to the exponent 1 is 2. And 2 to the exponent 0 is 1, which we've seen previously. So what we'll notice is that every time my exponent goes down by 1, I divide by 2. So what happens when I get into the negative exponents? Well, the pattern should still stay the same. I divide by 2 every time. So 1/2 divided by 2 is 1 to the power of 4. And divided by 2 again is 1 to the power, or 1 divided by 8. Just a reminder that we can write 1 to the power 1 over 4 as 1 over 2 to the power of 2. We can write 1 over 8 as 1 over 2 to the power of 3. Similarly, okay, in this case, if we subtract 1 from the exponent, okay, so I get 1 over 27. And as the exponent gets smaller, okay, what I'm actually doing here is I'm multiplying by 3. So my quantity is getting bigger by a factor of 3. So as my exponent is going down, I'm actually multiplying by 3 here. So that's weird. What happens when I have an exponent in the negative exponent in the denominator? Well, I have to follow the pattern. Okay, so 1 times 3 will be 3. 3 times 3 is 9. And 9 times 3 is 27. So what we can see, what we want to generalize here, is that if I have a base of a to a negative exponent n, what I do is I can imagine, like, you know, we said whole numbers can all be written over a denominator 1. What the negative exponent does is it boots that down into the denominator. Okay, and conversely, like if I just look here for a second, if I have 1 over a to the power of negative n, that's going to boot that up into the numerator. Okay, because 1 over what we didn't do here, which I meant to do, sorry, is we didn't write this using a base of 3. So I know that 27 can be written as 3 to the power of 3. So I know that 1 over 3 to the exponent negative 3 is 3 to the 3. So basically, you have to move the quantity from the numerator to the denominator or from the denominator to the numerator, and to simplify a negative exponent. So in this case, it would be numerator to denominator. And in this case, it would be from denominator to numerator. Okay, and don't forget we changed the negative n to a positive n. So let's apply this rule to a few questions. Okay, so again, we can think about all these whole numbers as being quantities over 1. So I'm going to move this 3, because the exponent is negative, I'm moving it to the denominator and I'm changing the exponent to be positive. Okay, so this again is a fraction over 1, but we have to be careful here because we have to move the whole entire base into the denominator. So in this case, I'm going to write this as 1 over negative 2 with brackets around it to a positive exponent 3. Now we said with negative bases and odd exponents, when we remove the brackets, this will be negative 2, like this, to the power of 3. I know overall the quantity in the denominator is negative, and we said we actually didn't like negatives in the denominator, so I'm going to move that negative to the top. Okay? So your final answer should have no brackets here unless they're fractions. Okay, we'll leave the fractions alone. Now in this case, just a really quick reminder that that negative is not part of the base. That negative is outside the quantity here. So I have a negative on the outside, and I'm going to write 4 to the power of negative 2 as 1 over 4 to the power of positive 2. Here, a really simple application of the rule. And now we're going to go into the rule of 1 over a to the negative n equals a to the positive n. So this one really simply is 2 to the power of 3. This one really simply is negative 3 to the power of 4, which we're going to rewrite because it's a negative base to an even exponent. Okay, it's 3 to the power of 4. Now for this one, the reason I put an asterisk beside both of these is because we're later going to learn, or we can do it now actually. So right now we know that this is, the final answer, but what we want to be able to do is simplify this. So anytime you have a fraction, what you want to do is think about this exponent 2 being applied to the numerator and the denominator within the fraction. So to simplify this, what we're going to do is write this as 1 to the power of 2 divided by 4 to the power of 2. Okay, big denominator here. 1 squared is 1, and 4 squared is 16. Now, if you think all the way back to one of our first lessons for dividing fractions, we said we could write 1, any whole number, as a fraction over 1. Okay, so we're taking this whole number here and writing it as 1 over 1, 1 over 16 as 1 over 16. All right, and then to simplify this, we multiply by the reciprocal of the denominator, and we get 16 here. Okay, for the next one, and what you might notice actually is that I'm basically just flipping the fraction around. So if I look at this, actually, we'll save that for next time. All right, so in this case, we have 1 over 6 to the power of positive 3, which we're going to write as 1 over 1 over 1 cubed, 1 to the exponent 3 over 6 to the exponent 3, 1 over 1 times 6 over 3, 1 to the 3. Now, I know that 1 to the power of 3 is just 1, so I can get rid of that. And basically, what this boils down to is the final answer is 6 to the power of 3. Okay? I'm going to tell you one common mistake made with negative exponents, which I really, really don't want you to make, so please beware of this, okay? I'm not really sure, when guys are doing a lot of work and I'm not sure exactly what happens, but I think they just confuse this rule sometimes. So sometimes guys see something like this, they see 2 to the negative 3, and they tell me, actually, you know what, that's negative 2 to the positive 3, okay? But we're not going to do that because we know a negative exponent actually implies moving something from the numerator to the denominator. So we know that 2 to the negative 3 is actually 1 over 2 to the positive 3. So these are very different answers, okay? So beware, please don't make that mistake. When you have a negative exponent, you have to either apply the rule a to the negative n is 1 over a to the n, or 1 over a to the negative n equals a to the positive n. So beware, negative exponents do not mean you move the negative to the front of the power. Okay, as always, we're here for extra help, and please reach out if you have any questions.